Combat footage routinely documents a specific event. The T-72 turret ascends tens of meters post-penetration. This visual evidence serves as a concrete starting point for deconstructing the internal layout. Why does the turret detach from the hull? The answer lies in the strict spatial limits of the fighting compartment. Ammunition detonation triggers an instantaneous pressure spike. Propellant gases expand in milliseconds. The pressure shears the ring bolts. A 12-ton steel module physically separates from the chassis. This event is not a random mechanical anomaly, but rather a systemic engineering consequence of a design prioritizing extreme compactness. Designers subordinated human factors to structural limitations. For the tank crews, existing within this confined architecture became a daily routine. They accepted the physical reality. The scale of this socio-technical standard is vast. State facilities manufactured over 20,000 units. This precise quantity can equip every active tank battalion in modern Europe several times over. The platform defines the mechanized core of multiple geographic regions. Active deployment continues today in Ukraine. Both opposing militaries deploy the system. The exact number of nations continuing to operate this platform today is 40. Engineers designed this platform produced in 20,000 units for a specific global reality. The objective was survival. The military demanded operation in a radioactive wasteland. How do you breathe on a contaminated battlefield? Through a system of special filters isolating the fighting compartment from the outside environment. To achieve this isolation, an inflatable rubber seal expanded. It physically blocked the turret from rotating. The same mechanism allowed the vehicle to ford rivers. Tanks drove across the riverbed at a depth of up to 5 meters. A deployable snorkel tube supplied oxygen. This formed the core of the nuclear, biological, and chemical protection system. Upon activation, the interior immediately filled with the specific smell of rubber and stale air. The heavy ring pressed tight against the steel. The tank became a hermetic capsule. The operators endured absolute physical isolation. External water pressure made opening the hatches impossible. Toxic environments dictated the same rule. Planners ignored human comfort. The design prioritized baseline survival during a nuclear exchange. The crew blocked the turret mechanisms to ensure complete sealing. Sealing the turret while maintaining a combat mass of exactly 40 tons required radical dimensional compression. Engineers sacrificed internal space. They reduced the crew to 3 men: driver, gunner, commander. Soviet designers removed the human loader. A mechanical autoloader took the vacant position. The machine executes the loading sequence directly inside the tight compartment. The cassette lifts from the floor carousel. A mechanical rammer aligns the massive 125mm smoothbore shell. It drives the munition straight into the gun breech. A sharp metallic clank reverberates inside the steel capsule. The heavy mechanism operates mere inches from the gunner's elbows. The interior layout leaves zero vertical clearance for a standing person. Spatial priority belongs entirely to the automated loading system. The total internal armored volume measures just 11.8 cubic meters. This strict architectural constraint dictated human physiology. Military recruitment boards enforced rigid anthropometric height limits for all conscripted personnel. The vehicle design physically rejected taller soldiers. The resulting profile remained exceptionally low. Total target area decreased. At 40 tons, the chassis provided high strategic mobility. Forward velocity on paved surfaces reached 70 kilometers per hour. Tactical withdrawal mechanics offered a stark contrast. The transmission restricted maximum reverse speed to 5 kilometers per hour. Operating a 125mm gun within such strict physical constraints required a system accessible to standard conscripts, not just career professionals. Who was the intended operator for Object 172? The target demographic was the mass conscript army rather than elite divisions. Soviet military doctrine relied on sheer demographic scale. Earlier designs established this industrial baseline. Factories across various nations manufactured an estimated 100,000 units of the T-54 and T-55 series. It remains the highest production volume in armored history. Quantity dictated strategy. The introduction of the T-74 disrupted this established model. It brought revolutionary composite armor and an advanced automated loading mechanism. But this technological leap carried a strict sociological cost. The new platform demanded highly trained crews with specialized technical education. Soviet strategic planning dictated the annual draft of over 1 million 18-year-old recruits. A global conflict meant fielding this exact demographic immediately. The Ministry of Defense needed hardware that raw recruits could master during a standard 6-month training cycle. The T-74 failed this demographic test. Engineers initiated a deliberate technological regression. They took the advanced framework and stripped it down. Technicians systematically dismantled the sensitive electronics. Assembly lines integrated simplified, rougher mechanical nodes to guarantee uninterrupted mass conveyor production. Visual inspection of the hull revealed utilitarian, unpolished weld seams. The driver compartment featured Spartan, heavy-duty analog controls. Designers engineered every lever and switch for crude physical manipulation by inexperienced hands. This simplified prototype became Object 172. The project documentation carried a definitive bureaucratic classification. A red ink stamp on the primary blueprints labeled it a mobilization model. State planners intended to activate this design only during total war. The high-tech T-64 and subsequent T-80 platforms remained strictly with specialized Guards tank divisions. The T-72 served as the expendable utilitarian alternative. However, production soon expanded beyond internal wartime contingencies. Export markets opened, initiating mass manufacturing and direct deliveries to Arab states. The internal volume of the tank dictated its engineering. The severe physical constraints of the original Cold War blueprint made automated loading inevitable. What is the time cycle of the mechanism? Exactly 8 seconds for one shot. The rotating carousel sits directly under the turret floor. It holds 22 rounds. The system executes a strict 2-stage sequence. First, the mechanical rammer pushes the heavy projectile into the breech. Second, it feeds the propellant charge directly behind it. The main gun fires. A sharp metallic clank cuts through the intercom static. The mechanism violently ejects the spent stub casing through a small hatch in the turret roof. This mechanism directly replaced human muscle. A highly trained crew member can load the first 5 rounds faster, but the physiological limit remains absolute. Inside a deeply confined Soviet turret, a human loader quickly depletes his stamina. The air fills with cordite fumes. Spent casings clutter the restricted floor space. The soldier must physically dig through racks for specific ammunition. The autoloader ignores biological fatigue. In theory, it maintains a continuous operational pace. It sustains the exact same speed from the first shell to the 22nd. No exhaustion. No human error. The system selects high-explosive, armor-piercing, or anti-tank rounds at the push of a button. But technical failures expose the underlying vulnerability. When the automated system breaks down, the crew must take over. The gunner abandons his primary stance. He grips the manual override handle. Raw physical effort replaces automated power. The soldier cranks the heavy metal carousel by hand. The rotation is painfully slow. The gears resist every single turn. The 2-stage feeding process drags. The combat efficiency of the tank plummets instantly. The manual rate drops to exactly 2 shots per minute. Human capital deficits entirely negated the mechanical advantage of the autoloader when export models reached the Middle East in the 1980s. In the Bekaa Valley, the Syrian army deployed the platform against Israeli forces. The operational failure was immediate. Tank battalions advanced in a tactical vacuum. Commanders executed zero coordination with infantry elements or artillery branches. Isolated armor drove blindly into prepared kill zones. The Iran-Iraq War exposed the exact same systemic flaw. Iraq deployed its newly purchased inventory directly to the front line. The crews lacked basic institutional preparation. Deliberate manufacturing choices compounded this deficit. Soviet export policy dictated the removal of advanced fire control systems, leaving poorly trained operators completely exposed. The vehicles lacked modern night vision and laser rangefinders. Operators could not compensate for the missing technology. Engineering solutions became irrelevant. The human capital failed. Western intelligence analyzed these early combat engagements. Analysts documented the poor operational metrics and subsequently downgraded their overall threat assessments of the platform. But the core ballistic danger remained intact. The 125mm gun retained the kinetic capacity to penetrate any contemporary NATO main battle tank. The operational deficiencies of Syrian and Iraqi crews intersected with a fatal structural baseline. Inside the fighting compartment, operators sat directly on top of exposed explosives. The architecture guaranteed a chain reaction of internal detonations upon any structural failure. Why were the anthropometric standards for Soviet tankers strictly regulated? The internal geometry of the turret physically excluded the placement of taller personnel. The military capped the maximum allowable height at 175 centimeters, or 5 foot 9 inches. Entering the vehicle initiated a biomechanical trap. The commander and the gunner dropped through the upper hatches. Their seats locked onto the rotating floor mechanism. Steel walls closed in. The massive breech block of the main gun divided the space. Shoulders touched steel. After sustained firing, this breach radiated extreme heat. Temperatures spiked. The crew operated inside an unventilated thermal oven while inhaling residual powder gases. Total internal volume measured roughly 13 cubic meters, whereas standard Western platforms provided nearly 20. Exactly 20 additional projectiles created a secondary hazard. The design distributed these extra munitions entirely outside the mechanized system. Personnel strapped them into any available structural recess. Against the hull, behind the operating seats. These charges utilized semi-combustible casings manufactured from pyroxylin cellulose. No protective shielding. When incoming kinetic penetrators breached the armor layer, spalling generated high-velocity metallic fragments. The kinetic friction created an intense shower of thermal energy across the entire compartment. A single spark contacted the exposed casings, and the dispersed propellant charges detonated instantly. This architectural blindness became a fatal liability in 1991. Iraqi crews confronted the networked warfare doctrine of the United States. How did outdated optics dictate crew survivability? Coalition forces destroyed vehicles from several miles away, long before visual contact. Operation Desert Storm redefined armored combat in the 1990s. Iraqi operators sat isolated inside their cramped turrets. Outside, a dense wall of flying desert sand swept across the battlefield. The storm completely blocked optical visibility for analog sights. The human element became totally disconnected from the external environment. They saw nothing. The opposing force deployed Abrams tanks and Bradley fighting vehicles. The technological disparity left the outdated Soviet platforms defenseless. Abrams units utilized 120mm guns. They fired high-velocity APFSDS rounds. American armored divisions operated laser rangefinders and thermal imagers directly through the dust storms. The network calculated precise trajectories, while the Iraqi operators stared into opaque glass. The crews could not react. By the 2020s, the proliferation of expendable drones and javelin systems generated an unprecedented sociological anomaly. Tank crews initiated unauthorized mass modifications of their vehicles. Mechanics stripped steel bed frames. They gathered rusty industrial fencing and iron pipes from abandoned construction sites. Torches sparked in field camps. Crews independently welded these raw metal grids directly onto standardized Soviet turrets. The structures formed crude, rust-covered canopies over the commander hatches. Why did crews modify factory equipment with scrap metal? It was a psychological imperative to create at least some physical barrier against shaped charges attacking from above. The T-72 platform faced a terminal design flaw. Decades of engineering prioritized frontal glacis protection. The hull carried over 500 millimeters of composite armor. The roof plates measured barely 40 millimeters. The NLAW and Javelin anti-tank guided missiles exploited this exact structural disparity. They bypassed the primary defense sector entirely. Missiles climbed to 150 meters. They plunged directly into the least protected upper hemisphere. Heavy frontal armor became mathematically irrelevant. Commercial quadcopters delivered standard anti-tank grenades vertically. The makeshift metal grids provided zero ballistic resistance against modern penetrators. They functioned strictly as a psychological shield for isolated operators. The physical mechanics of destruction remained absolute. A shaped charge penetrated the 40-millimeter roof plate. The superheated copper jet reached the autoloader carousel containing 22 exposed high-explosive rounds. Simultaneous ignition of the propellant charges initiated the jack-in-the-box effect. A catastrophic high-pressure internal explosion physically severed the 12-ton turret from the chassis. This catastrophic structural failure exposes a profound macroeconomic crisis. A $2,000 drone systematically neutralizes a multi-million-dollar platform. The financial asymmetry is absolute. The macroeconomic model collapsed. State contractors spend millions to manufacture heavy vehicles, while commercial vendors supply lethal quadcopters for $2,000. This exchange rate renders isolated armored formations mathematically unviable. Traditional armor cannot offset mass-produced commercial electronics. Doctrinal survival strictly requires dense infantry screens. Dismounted soldiers clear sightlines. Without infantry, armored units operate blind. Tactical isolation guarantees destruction. Previous conventional wars documented this exact vulnerability. Opposing forces systematically destroyed unsupported M60 Patton and British chieftain formations using T-72 platforms. The winter assault on Grozny brutally documented the fatal geometry of urban warfare. What happens when an armored column enters dense infrastructure without infantry screening? The 131st Brigade effectively ceased to exist in 48 hours. Chechen combat teams occupied basements and upper residential floors to establish interlocked fields of fire. The ambush mechanics were strictly sequential. The fighters allowed the lead vehicles to pass. Then they targeted the rear echelon. Cheap RPG-7 grenade launchers disabled the trailing chassis. The column halted. A concrete corridor trapped the battalion. The crews attempted to return fire. They hit a mechanical limit. The main tank guns lacked the elevation angle to target the upper floors. The human cost of this tactical failure fell entirely on unprepared troops. On New Year's Eve 1994, command pushed these units toward the central railway station. The personnel consisted predominantly of teenage conscripts who possessed absolutely no combat experience or specialized training for high-density urban environments. They drove blindly into a pre-planned kill zone. Brigade Commander Colonel Ivan Savin desperately requested artillery support. He died attempting a breakout. Opposing forces executed the trapped crews methodically. Dense black smoke obscured the avenues. Dozens of burnt tank hulls clogged the narrow intersections. Torn-off turrets rested on the shattered pavement. Over 800 soldiers suffered fatal wounds or severe injuries. Out of the initial 120 deployed platforms, the brigade irrecoverably lost 105. To prevent further manpower depletion, the military bureaucracy rewrote its operational doctrine. The institutional response materialized before the Second Chechen War. Commanders changed the deployment rules. Infantry screened the advancing columns. Heavy artillery leveled city sectors before armor advanced. Engineers worked concurrently to increase crew survivability. Rectangular blocks of Contact 1 dynamic protection densely covered the frontal armor of modernized machines. Each external cassette housed 2 explosive elements. Counter detonations successfully deflected standard-shaped charges. Tactical adjustments and structural modifications yielded direct results. Irrecoverable equipment losses dropped significantly during the campaign. Modernization programs extended the platform lifecycle throughout the following decade. Technicians upgraded fire control parameters. They installed newer reactive arrays, but the underlying architecture remained tied to obsolete mass production concepts. Then came Syria in 2011. Urban combat resumed. Militias deployed modern anti-tank guided missiles, or ATGMs. Operators engaged targets from distances exceeding 1 mile. Tandem warheads bypassed the reactive defense parameters entirely. Engineering additions only temporarily delayed the inevitable survivability crisis. The outdated platforms offered zero protection.